All right, so we're looking at ratios and rates and proportions this week. Before we jump in, take just a second. What do you already know about ratios? So ratios are relationships between two numbers, like 6 cups of water to 3 cups of rice, or 8 slices of pizza to 1 pizza box, or 60 minutes to 1 hour. And these relationships exist in a way that if we change one of these values, we must also change the other value to make sure that the relationship remains the same. So, for example, if we're looking at 60 minutes to 1 hour, if I change this 1 hour to 2 hours, I've only added 1 to the hours. But I can't just only add 1 to the minutes because I know that 2 hours is not 61 minutes. So it's saying that the relationship has to remain the same no matter what the values are. So if I change this to 2 hours, I'm doubling this value, which means I must also double the other value. So I know that 2 hours is the same as 120 minutes. So the ratios exist in a fixed relationship to one another. And we can change the values as long as we change them in a way that the relationship remains the same. And we can write ratios in different ways. We can write it as A to B, where we use the word to. We can use a colon, those 2 dots, or we can use it as a fraction, where we have A over B. And we will mostly be using the fractional representation in our class because that's the easiest, I think, to work with. But I just wanted to show you these different ways because you might see different ways represented, and we want to make sure everyone's familiar with all of those ways. So really, we could compare as many things as we want with a ratio. For example, when I'm making bread, I use this ratio where I have 3 cups of flour to 1 cup of water to 2 tablespoons of sugar to 1.5 teaspoons of yeast to 1/4 cup of oil to a teaspoon of salt to a teaspoon of rosemary. And you may be thinking to yourself, hold up, that's just a recipe. And you're right, because recipes are ratios. If I double a recipe, I have to double everything in the whole recipe. If I add an extra cup of flour, I have to make sure that I change everything else in the recipe to maintain the same relationship between all of the ingredients. On the plus side for our class, we will only be really working with 2 things that we're comparing at a time in a ratio and not a whole recipe. So think about this. If I have a fraction, half of a sandwich, that's half of a sandwich, right? But if I write it as a ratio where I have 1 sandwich to 2 people, I still have 1 over 2. 1 sandwich to 2 people. Hopefully, unless you are an unfortunate younger sibling in your family, if you have 1 sandwich and 2 people, each of you are getting 1/2 of the sandwich. We can also use it to compare things like this. So in this picture, we have a ratio of 4 dogs to 2 cats. And as I'm looking at this, I see I have 4 over 2, which with fractions, I would be asked to simplify. And in the same way, we can simplify ratios, where if I had 4 over 2, I could simplify it as 2 over 1. Because 4 over 2 and 2 over 1 have the same relationship to one another. And we want to be really careful when we're thinking about the order of our units, because the thing that I say the first is the thing that is going to show up first in my ratio. So if I have, for example, 3 mandarin oranges for every 1 student, the ratio of mandarins to students is going to look different from the ratio of students to mandarins. So if I say the ratio of mandarins to students, I'm representing that as 3 to 1. But the ratio of students to mandarins is 1 to 3 because I've said students first. Now let's do some practice simplifying this ratio. When I look at this, it is difficult for me to process the information when it's written with a colon. So I'm going to rewrite it as a fraction. For you, if it's easier to process it written linearly like that, go for it. Use whatever tools are the most helpful for you to process the information. For me personally, a fraction is easier. Now, when I look at this, I can see, okay, well, I know that 18 times 2 is 36, which means 18 goes into both of these things. So I'm going to divide the top and the bottom by 18 because remember, just like with a fraction, I can do anything I want as long as I do the same thing on the top and the bottom. Well, now I have 2 minutes to 1 minute because 36 divided by 18 is 2 and 18 divided by 18 is 1. So I've simplified the ratio of 36 minutes to 18 minutes as 2 minutes to 1 minute. Now there are some where it might be helpful to convert the units so that we can more easily compare them. We have a couple options though. You don't have to always convert the units. So for example, here I have 2 feet to 14 inches. If I don't want to change anything, I don't need to. And I'm going to say, okay, I know 2 goes into both of these. So now I have 1 foot to 7 inches. And that's my simplified version. Whereas here, I have 5 feet to 74 inches. From this, 5 and 74 don't have a number in common, so I can't simplify it any further than this. However, if I convert these feet to inches so that I'm comparing inches to inches, right? So if I have 5 feet and I want those to be inches, I'm going to multiply by 12 because there are 12 inches in 1 foot. And I get 60 inches. So now I have 60 inches over 74 inches. And now 60 and 74 do have something in common. So I'm going to start with 2 because I can see they're both even numbers. And I have 30 inches over 37 inches. And now I think that is as simplified as it can be. So I don't always have to convert them if I don't want to, but sometimes it is helpful to convert them so that I can simplify a little bit more. Pause this video and give these a try. All right, so with this first one, I have $1 to $2.50. As it is, I can't really simplify them much more, but I'm going to rewrite them as cents because now I have these whole numbers that I can simplify. And so I see from both of these, they have an extra 0 at the end, which means I can take 10 from both of these and still have a whole number. So 100 divided by 10 is 10, and 250 divided by 10 is 25. Now I can see from 10 and 25, I have a 5 in common with both of these. And 10 divided by 5 is 2, and 25 divided by 5 is 5. So in this ratio of $1 to $2.50, in its most simplified form, I have 2 cents to 5 cents. Now here I have 72 feet to 63 feet. And I'm looking at this, they are not even numbers. So, well, they're not both even numbers. So I can't divide both sides by 2, but I think I can divide both sides by 3. And there's a trick to find out if you can divide something by 3. So if I take these digits, 72 and 63, if I add the digits together, 7 plus 2 is 9, and 6 plus 3 is 9. And 9 is divisible by 3, which means that 72 and 63 are also both divisible by 3. So I'm going to start with 3 here. They might be divisible by 6 or by 9, but I'm going to start with 3 because I know that they can be divisible by 3. So 72 divided by 3 is 24. And 63 divided by 3 is 21. Well, now I'm looking at these and I see, okay, I have 24, which again, let me see, 2 plus 4 is 6, and 2 plus 1 is 3. So they're both divisible by 3 again. 24 divided by 3 is 8. And 21 divided by 3 is 7. And now, here I am, 8 feet to 7 feet is my most simplified form. Now with these, 32 to 56, I'm going to divide both of these by 8, and I get 4 over 7, and here I have 30 to 20. I'm going to divide both of these by 10, and I get 3 over 2.